Hello engineers. So last class we discussed some tool. Okay, that we have a cadence. In a cadence we simulate that ID versus VGS graph, ID versus VDS graph with respect of different VD W by L and different VDS. Okay. So basically till now we discussed that MOSFET is a symmetric in nature and this is a voltage controlled current source device, and as per the variation of the parameter, let the W by L variation, you can find that the current will be vary, the current will be increased, and MOSFET have a different reason, that is linear, saturation, cutoff, okay, subthreshold. Okay, so MOSFET is on, it mean that it may be in linear, it may be in saturation. If VDS is less than VGS minus VTS, so I can say that the MOSFET in a linear region. If VDS is greater than VGS minus VTS, then we can say that this is a saturation region. This is for NMOS. Similarly, for PMOS, you are writing that VSD less than VSG minus VTS, so it will be a linear region, and VSD is greater than VSG minus VTS, so you can say that the MOSFET in saturation region. And the current is ID is equal to mu n CUX W by L, VGS minus VTH ka whole square half, that will be a saturation current, and ID is equal to mu n CUX W by L, VGS minus VTH into VDS minus half VDS square, that will be a linear equation. And after that we discuss that transconductance. The transconductance means the current is changing, the output current is changing by the small amount of changing of the input voltage, that is represented the transconductance. And transconductance is very important topic when we talk about the amplifier. So today we are going for the understanding about NMOS and PMOS charging and discharging. Okay, so let's talk about that charging and discharging. So let we have a PMOS, and PMOS, that symbol is like this, and we are using that PMOS as a charging element, that I am using a capacitor, and this capacitor will be charged by the help of MOSFET, where that source have a supply is VDD, and here that supply is ground. Basically PMOS is on at logic 0 and NMOS is on at logic 1. So I am just assuming that PMOS have a gate input voltage is 0, and that source have a VDD, and the drain side you have a capacitor voltage, where the initial voltage of the capacitor is 0 volt. Okay, so this have a higher potential, so it will be source, and this will be a drain for PMOS. The higher supply, that higher node will be represent your source, and the lower node will be represented as drain. Okay, so by the looking of the circuit, what is this, that VSG is greater than equal to mod VTH. That will be the basic condition for MOSFET on. The source voltage is VDD and gate voltage is 0. This is greater than mod VTH. So by the looking of the equation, that VDD is always be greater than mod VTH. So that means if gate voltage is 0 and the source voltage is VDD, the MOSFET is always on, and this capacitor will be charged. There is no any dependency of the capacitor voltage to determine that MOSFET on is off. It may be linear, it may be saturated, it depends on the other things, but I am just thinking in a way that MOSFET in as like a switch, and here that capacitor, that input voltage is 0 and source voltage is VDD, so VDD minus 0 is greater than mod VTS, so always MOSFET is on, that PMOS is always on, so that capacitor will be charged through that MOSFET towards the VDD. So capacitor voltage can be equal to VDD, and there is no meaning of that VSG, because as per capacitor will be charged, it can charge till VDD. Okay, it will not charge more than that or less than that. Okay, it will be decided that VSG is greater than equal to VTS, so the MOSFET can charge. Okay, so this is the fundamental of the PMOS charging. Let's talk about NMOS charging. You have a NMOS, and this NMOS you have a gate voltage, and I am just assuming that gate voltage is high, and this voltage is VDD, and this capacitor have a voltage like this. So what is happening? The gate voltage have a high, means this is a VDD, the gate voltage is VDD, and the source voltage is VC. That the source voltage is what? That the initial voltage across the capacitor is 0 volt, and I am saying that this voltage is VC. So the basic condition of the MOSFET is what? That is VGS, that VGS is greater than equal to mod VTH or VTH. Gate voltage is VDD. Source voltage is VC, not 0. Here the source voltage is capacitor voltage. The source voltage is a capacitor voltage, that is VC, is greater than equal to VTH. So the capacitor can charge till VDD minus VTH there. Capacitor can never be charged through the NMOS to VDD. It will be charged till VDD minus VTH. That's why NMOS is not good for passing logic 1. Okay, if this have a source is drain is VDD, so capacitor can charge till VDD minus VTH. Because VGS greater than must be greater than equal to VTH, so the difference of this is must be greater than equal to VTH. So that capacitor can never be charged more than VDD minus VTH. If it is trying to become a more than VDD minus VTH, the MOSFET will off. This is the condition like this, ki MOSFET is on here, the capacitor is charging by this help of the current, that the drain current. Okay, it can be linear, it can be saturation, I am not going here, but I am just thinking in a way that VGS is greater than VTH, that MOSFET can be linear or saturation, and the current is flowing here. As per capacitor is charges, as the source voltage increases, it will be increases from 0 to some voltage to some voltage to some voltage. After that it will be reaches to VDD minus VTH. Once it will be reaches to VDD minus VTH, the difference of gate to source voltage is not be equal to VTH, it may be less than that. Once that it will be equal to VTH, then MOSFET will be off, it is like a switch open. And if the MOSFET is like open, this supply will be not connected to capacitor, and this drain current is 0. So that capacitor will charge till VDD minus VTH. So through the NMOS, you can't charge till VDD, it will be charged to maximize VDD minus VTH. That's why NMOS is not good for charging. Where that when PMOS is good for charging. That's why always we are using a pull-up network as a PMOS. Whenever you are using a pull-up network, the pull-up network is PMOS. This is hanging with the VDD. They are pull up towards VDD. Why? Because this is good for charging. They will provide the maximum voltage on the source, that is VDD. But if you are using a NMOS as a pull-up network, it will not charge till VDD. It will be charged less than VDD. It will be VDD minus VTH. That's why always we are using that pull-up network as a PMOS and pull-down network as a NMOS. Let's talk about discharging. So you have a MOSFET, and this is PMOS, and this is logic 0. That capacitor is discharges with the help of PMOS. In the first case, we are making that PMOS is charging. Second case, we are making that NMOS is charging. Now the third case is a PMOS is discharging with that capacitor, and the capacitor have a voltage is initial voltage is VDD. It's not a DC voltage, it's a capacitor voltage. The initial voltage is VDD. And now this capacitor is discharging with the help of PMOS. So what is happening? If you are thinking that this is a higher voltage, that is a source, This is a lower voltage, that is drain, and this is gate. So using a very basic equation that VSG is greater than equal to mod VTH, the source voltage is VDD and gate voltage is 0 and it is greater than equal to mod VTH. And this VDD is what? That capacitor voltage. This is not VDD. We are thinking this is not a DC voltage. This is a capacitor voltage. So I am writing not a VDD. It is VC. So VC, that is capacitor voltage at the source side, that VSG, that VDD minus 0 or VC minus 0 is greater than equal to VTH. Capacitor is discharged towards the ground with the help of PMOS, but the capacitor will not be discharged less than VTH. It can be discharged till VDD to VTH, but it can't be discharged with the PMOS to what's that ground. So capacitor is discharging, but till VTH only. Why? Once it will be nearly to VTH, that the problem is arising that MOSFET may be it open. So that capacitor will discharge from VDD to VTH. After VTH, this source will not be discharged. This capacitor voltage will not discharge because that MOSFET will be off. Till MOSFET is on, then capacitor will charge. Capacitor can discharge. Once that MOSFET is open, this capacitor will not discharge. So capacitor is discharging from VDD to VTH. After that the MOSFET have a VSG is greater than equal to VTH condition will fail once that capacitor is below that VTH. So that's why this MOSFET is off and this capacitor will not be connected to the ground or with the PMOS, so that capacitor will remain the voltage till VTH. So capacitor is discharging from VDD to VTH, not at VDD to 0. Similarly, if you talk about NMOS, in NMOS, you have a gate voltage, you have a drain voltage, this is 0, this capacitor have a voltage is VDD, and this is NMOS. So what is the condition of the MOSFET for on? That VGS is greater than equal to VTH. The gate voltage is high for a NMOS and the source voltage is 0 greater than equal to VTH. This is source, this is drain, this is gate. The gate have a higher potential, the source have a lower potential, that is ground, that is VDD minus 0 is greater than equal to VTH. This MOSFET is always on. The NMOS is always on because VDD is always greater than equal to VTH. The MOSFET NMOS is always on for the discharging, and this capacitor can discharge with the drain current, and that the drain current is flowing through this, and the capacitor voltage VC is discharged from VDD to 0. That's why NMOS is good for discharging and PMOS is good for charging. So I am writing in such a way that you have a PMOS and you have a NMOS. In charging and discharging. In a charging, what are you saying? That simply what will be happening, that PMOS is good for charging, the gate voltage is 0 and PMOS is good for charging. It can be charged that capacitor to VDD voltage, where that drain side, that have a source side have a VDD and gate side have a 0. So VSG is always greater than mod VTH. So that drain voltage is properly have a current, and the drain current may be linear, may be saturation, but it can be charged till VDD. But when you talk about PMOS for discharging, it will not discharge to 0, it will discharge till VDD minus VTH. The capacitor is discharging where that VSG is greater than equal to 0, that capacitor voltage must be greater than equal to VTH, that capacitor will never be less than VTH, then MOSFET will be off. So PMOS is good for charging, but it is not good, it is not okay. So this is VDD, not VTH, it is mod VTH. Okay, it will not discharge till ground, it will be discharged till mod VTH. Okay, it will be not discharged till 0. Okay, similarly for NMOS, if you are looking for NMOS it not good for charging, it can charge till VDD minus VTH. It never be charged till VDD. It can charge capacitor from 0 to VDD minus VTH. Where that NMOS is discharging, it can discharge till 0. The capacitor can discharge from VDD to 0. So that is the way that you can understand that PMOS is good for charging and NMOS is good for discharging. That's why always that one of the question can ask in an interview, why we are taking as a PMOS as a pull-up network, or why we are taking as NMOS as a pull-down network. So PMOS is good for charging. It can charge till maximum voltage of the drain of the source side, and the drain voltage can be towards that source voltage, where that NMOS is good for discharging. That's why we are putting that in a pull-down network. It can discharge towards that ground. If you are using a NMOS as a pull-up network and PMOS as a pull-down network, it will be never work as that Vout never be equal to the source voltage, and for PMOS Vout is never be towards that ground. It is like in between VDD minus VTH to mod VTH. Okay, so that's why that this is the problem here, that PMOS is always as a pull-up network and NMOS is always as a pull-down network. In a CMOS inverter also we prefer that PMOS as a pull-up network, and everywhere whenever you are looking the circuit, that PMOS is a pull-up network and NMOS is a pull-down network. Okay, let's talk about that one question we have. Okay, that here is 5 volt, here is 5 volt, here is 5 volt, here is 5 volt. What is Vx, what is Vy, and what is Vz when the threshold voltage of the MOSFET of all the MOSFET is equal to 1 volt. Let I am assuming the threshold voltage of the MOSFET is 1 volt. What is Vx, what is Vy, what is Vz? Yes, anyone? What is Vx, what is Vy, what is Vz? Where that threshold voltage of the CMOS, the threshold voltage of the MOSFET is 1 volt. Okay, you are checking that what will be the voltage across that Vx, Vy and Vz when that the gate voltage is 5 volt and you have a input voltage is 5. What is Vx, what is Vy, what is Vz? You just think in such a way, okay, let assume it this is have a capacitance here. We have a capacitance here, we have a capacitance here, and we have a capacitance here. That is, that will be a Vx, that will be a Vy, that will be a Vz. And now tell me what is the Vx, what is Vy, what is Vz? If that threshold voltage of the MOSFET is 1 volt. So let that initial voltage of the all the capacitor is 0. Initially that is Vx, Vy and Vz was 0. Okay, so just solve it. That is what is happening here. Okay, so if you are looking the circuit, just think in a way, okay, that this is drain, this is NMOS, this is drain, and this is source for this, that VGS is greater than equal to VTH, that is 5 minus Vx is greater than equal to VTH. So Vx must be less than 5 minus VTH, that will be 4 volt. Vx can be a 4 volt, and the drain have a 5 volt, so it will be occur to 4 volt. If this drain have a 3 volt, it cannot be 4 volt, it will be 3 volt. The drain voltage will be defined that Vx, that drain is 5, so Vx can be 4. If Vx is drain is 3 volt, so Vx never be 4, Vx will be 3 only there. So that is Vx voltage will be a 4 volt, and if your increases after that, this MOSFET will be off, the drain and source will be disconnected, this will be a switch open. Okay, similarly here, what is Vy? So if you are looking that 5 minus Vy is greater than equal to Vth, so this is 5 minus Vth greater than equal to Vy, so Vy is less than equal to 4 volt. So this Vx is a 4 volt, so this can be a 4 volt, because the drain voltage of this will be a drain for that, and this is a source of this MOSFET. Okay, so this is the drain is 4 volt, so this will be can be a 4 volt, so that Vy will be a 4 volt. Okay, similarly this Vz is also be a 4 volt. Just check it. What that 5 minus Vz greater than equal to Vth. So 5 minus Vth greater than equal to Vz. So Vz less than equal to 4 volt. So Vz can be a 4 volt, Vx can be 4 volt, Vy can be a 4 volt, and Vz can be a 4 volt. So this is the question, and you can understand what is happening in this. Okay. Okay, take your time and understand this question. This is very simple. We can make that tough one question also, but for basic understanding, you must have a understanding of that. Okay, this is NMOS. It can't be charged to VDD. It will be charged to VDD minus VT. The drain have a 5 volt, so 5 minus it is 4. Okay, so this will be a 4, and this is also 4, so this can be Vy can be a 4 volt. Just check that what is the drain voltage, it is 4 volt, so you can. Okay, and this is also can be a 4 volt. Okay, let's talk about another question here, that you have this one. This is 5 volt, this is 4 volt, this is 3 volt. I am just assuming that what will be happen, and let this is 4 volt. What is Vx, what is Vy, what is Vz? Just tell me. Okay, take your time, and where the threshold voltage of the all the MOSFET is 1 volt. I am just assuming that the threshold voltage of the all the MOSFET is 1 volt. What is Vx, what is Vy, what is Vz? And this is very important question. This type of question in asked in an interview, what is the pass transistor voltage of Vx, Vy and Vz? So that the drain side have a voltage. Of course, this is looking like what that have a everywhere have a some capacitance. Just I am assuming that this is a capacitor here, this is a capacitor here, and this is capacitor. And just I am assuming with respect of this node voltage always with respect of ground, I am just assuming this is a capacitor here, this is a capacitor here, this is a capacitor at Vx, Vy, Vz. What will be the voltage at Vx, what will be the voltage at Vy, what is the voltage at Vz? Just tell me what is Vx, what is Vy, what is Vz. If you have a drain voltage, of course this is a drain voltage because this is a NMOS. In NMOS the higher voltage is drain and the lower voltage is source. This is drain, this is source, this is drain, this is source. Just tell me what will be that voltage on Vx, Vy and Vz. Just focus on this question. Okay, focus it. Take your time and solve it. Okay, take your time and solve it. What is Vx, what is Vy and what is Vz? If you have a drain voltage 5 volt, 4 volt, 3 volt, and what will be the voltage at Vx, Vy and Vz when you have a drain voltage 5, 4, 3, and the gate voltage was the first MOSFET have a 4 volt, the second gate voltage decided by Vx, the third MOSFET gate voltage decided by Vy. Just tell me what is the voltage. Take your time and solve it. Okay. Yes, everyone. What is Vx? What is Vy? What is Vz? No? Okay. So what is Vx? What is Vy? What is Vz? If you are looking at this MOSFET, that 4 minus Vx is greater than equal to Vth. So this is 4 minus Vth is greater than equal to Vx. So Vx should be less than equal to 4 minus 1, that is 3 volt. So this will be a 3 volt. It can, that this Vx node voltage can be a 3 volt, it not more than 3 volt. That gate and source voltage have a difference of Vth. This will be 4, so this can be maximum is 3. 4 minus 3 is 1, that will be a MOSFET is on. So that is 3 volt. This will be the gate voltage of second MOSFET. If you are looking this MOSFET, that this is a 3 volt. What is Vy? 3 minus Vy is greater than equal to Vth. So 3 minus Vth, this will be a 2 volt. Okay. It can be a 2 volt because the drain have a higher potential. And here what is happening here, that will be, this is 3 volt. Okay, Vy minus Vz, Vy minus Vth is greater than equal to Vth. So 2 minus 1, that is 1, that will be a 1 volt. So Vz will be a 1 volt. So Vx can be a 3, Vy can be a 2, and Vz can be a 1 volt. This is a very basic question of the pass transistor. Okay, and that is the way you can understand. Okay, you have a MOSFET. In this MOSFET, what is happening? Okay, that what is 2 volt here? Where it is 2 volt? Where it is 2 volt? Vx, Vy, Vz is what? Vx is 3, Vy is 2, Vz is 1. Yes, please check it. It is correct or not? Okay, please check at your end that Vx, Vy and Vz. Okay. Okay. Okay, just tell me what is Vx, what is Vy, what is Vz, what is Va, where the threshold voltage of the MOSFET is 1 volt. Yes, please everyone. What is Vx, what is Vy, what is Vz when the threshold voltage of the MOSFET is 1 volt? Just tell me that what is the voltage here? What is Vx, what is Vy, what is Vz, what is Va? Okay, yes everyone. Please be focused. What is Vx, what is Vy, what is Vz? If you have this type of question. Yes, please take your time and tell me what is Vx, what is Vy, what is Vz. This is 4, 3, 2, 1. Let's check it. Okay, so this is 5 minus Vx greater than equal to Vth. So 5 minus Vth is greater than equal to Vx. So Vx is less than equal to 5 minus 1, that is 4 volt. So Vx will be a 4 volt. Let's talk about the Vy. If you talk about Vy, so Vy is what? That is 5 minus Vy is greater than equal to Vth. So Vy can be a 4 volt. Just check it, what is the drain voltage? The drain voltage is 4. So it can be a source voltage is 4. So Vy would be 4 volt. 4 minus Vz is greater than equal to Vz is 3 volt. Just check it, this is 3 volt. Okay, so it can be a 3 volt. And 3 minus Va is greater than equal to Vth. So Va is equal to 2 volt. The drain voltage is 2 volt. So it will be a Va is 2 volt. Okay, so firstly check that this is correct or not. That is 4, 3, 2, 1. This is 4, 4, 3, 2. Yes, hello. Yes, name is Mokas. I don't know that. Please check it. That answer is 4, 4, 3, 2. It is correct or not? That Vx will be 4 volt, Vy will be 4 volt, Vz will be 3 volt, and Va is 2 volt. From Vy explains her. Okay. Okay, so that what is happening? That you just think in a way, okay, you have a capacitor here, you have a capacitor also here, you have a capacitor also here, and you have a capacitor also here. Okay. Initially, all the voltage of the capacitor is 0. Okay. So once that you have a supply, so 5 minus Vx is greater than equal to Vth. So 5 minus Vx is greater than equal to Vth. So 5 minus Vth is greater than equal to Vx. So Vx is less than equal to 4 volt because Vth is 1 volt. So 5 minus 1, that is 4 volt. So capacitor can charge till 4 volt. Let's talk about Vy. So 5 minus Vy, the gate to source volt, because this is a drain voltage here. For this MOSFET is a drain, for this MOSFET is a source. This MOSFET is a drain, then this will be a source. And this is 5 minus Vy is greater than equal to Vth. So 5 minus Vth is greater than equal to Vy. So Vy is less than equal to 4 volt. So Vy can be a 4 volt if drain will allowed, and drain have a maximum voltage 4, so it can be a 4 volt. If it is 3 volt, so it can be a 3 volt. If it is 2 volt, so it can be a 2 volt. If it is 1 volt, so it can be a 1 volt. If it is 6 volt, then only it will be a 4 volt only. Okay, so the maximum voltage Vy is what? 4 volt. The maximum voltage is 4 volt. The Vy can be a maximum voltage 4 volt because Vgs is greater than equal to. So 5 minus 4 is greater than equal to 1. So Vy can be maximum voltage 4, but it will decided by the drain voltage. The drain or VDD will decide. The drain have a 4 volt, so it can be maximum to 4. Okay, but if it is 3 volt, so it never be 4. It will be 3 only. If it is 6, so it can be maximum is 4 volt. So that please focus on the drain potential also. Let's talk about Vz. So the gate voltage is 4 volt. That Vz is greater than equal to Vth. So 4 minus Vth is greater than equal to Vz. So Vz is less than equal to 3 volt. So Vz, the maximum voltage across that Vz is 3 volt, and it will be dependent on the drain potential. So that by this gate voltage, this will be the maximum voltage 3 volt. If the drain voltage is less than that, that will be the Vz voltage. If this is more than that, the maximum voltage is 3 volt. So Vz can be maximum to 3 volt and minimum it depends on the drain potential. Similarly, if you talk about that this Vz minus Va, so this is 3 minus Va is greater than equal to Vth. So Va is less than equal to 3 minus 1, that is 2 volt. So Va, the maximum voltage Va is 2 volt, but it depends on the drain potential. If it is less than 2 volt, so that will be your source voltage. But if it is not less than and equal to or more than that, so the maximum voltage of the VA is 2 volt. So this is the way you can analyze that PANS transistor based question. Yes, everyone, is it okay? So this is the way you can analyze the Vx, Vy, Vz and Va. Okay, I will give some questions and in just as a assignment if required. That lot of things we can do with that. Okay, but I am not going for this. We can use PMOS, we can use NMOS, we can use CMOS inverter, we can use lot of things in this question, but understand what is happening here. Okay, firstly understand what is the happening here so that you can analyze any type of question. Okay, okay, let's talk about that. Introductory of CMOS inverter. I am just giving the intro because CMOS inverter is very large topic. Okay, we can complete this CMOS inverter to approx in a 1 week. Okay, that because the CMOS inverter is too bulky topic. And let's start with this, that in a way, okay, you have a PMOS and you have a NMOS and the inverter is connected in such a way. This is a CMOS inverter. You can design inverter as many type, like you can design an inverter like this also. This is also behave like an inverter. Okay, you can say that this is also an inverter, this is also one of that inverter. Okay, you can use one NMOS also, and you can use this is also behave like an inverter. Okay, it depends on you. Okay, it depends. Okay, so of course it have a some problem, that's why we are not preferring this CMOS inverter. We are not preferring this type of circuit. We are preferring this type of, why? Because of course if you're looking this circuit, it have a resistance, it have a NMOS, with that it have a some current. Okay, so that complementary metal oxide semiconductor field effect transistor have a better idea in terms of static. If you are took in a such a way that static voltage, that let this is 0 volt or a 1 volt or a logic high or logic 0. If it is 0, this PMOS is on, it will be a maximum voltage VDD. If it is 1, then NMOS is on, this VDD, this capacitor will discharge, that V out will be 0. So I can say that for this type of circuit, that static power is 0, because in input is 0 or 1, that one of that MOSFET is active. That it can be PMOS, it can be NMOS, both MOSFET will not active in a static input. Whenever you have a input is high or low, whenever you have a high or low, one of the MOSFET is open, that is called static power dissipation of the CMOS inverter is 0. The static power dissipation of CMOS inverter is 0. Always be 0. Why it is 0? Because static means what? It is always be a 0, it is always be a 1. For static input, it will provide the static output. Okay, I am not talking about transient region, because in the transient region the output will be different. But in a static, when the input is 0, the output is high. When the input is 1, that output is low. When input is low, then output is high. Means one of that MOSFET is active and one of the MOSFET is off. That means the total current in a circuit will be 0. So that we can say that the static power dissipation of the CMOS inverter is 0. Okay, so that's why that CMOS inverter is preferable. Second thing, it have a PMOS and NMOS. It is a monolithography concept, that is in you can design a single chip. You can design a single chip that both PMOS and NMOS will be fabricated. So this is also a best advantage of this. Okay, and the second one is thing that it will provide the output rail to rail. Rail to rail means it will be reaches from VDD to 0 or V0 to VDD. It will provide to VDD to 0 output. I am not focusing on the input. Input can be anything from, it is not 0 to VDD or VDD to 0. It will be in between that. It will provide the higher voltage to lower voltage. So that output is always from VDD to 0 or 0 to VDD. So the output is rail to rail. Okay, so this is the way you can understand. Okay. Okay. So when that input is increasing, what will happen? That ideally we want that if you have an ideal inverter, so that V in is growing from 0 to VDD. If it is going from 0 to VDD, at VDD by 2, it is looking like perfect like this. It is perfect like this, that it is an ideal case. 0 to VDD by 2 the logic is high, the output will be high, and VDD by 2 to 0 it will be logic low, the output is low. But it is an ideal case. But if you are looking the practical case, of course the MOSFET have a resistance, of course it have a capacitance, that is CDS, or you can say that MOSFET have a resistance capacitance also. So it will not provide this type of, this is an ideal case. Practically it will be like this. Yes, hello. This the yellow one is a practical case, and the ideal case is that 0 to VDD by 2 the logic is high, and VDD by 2 is logic 0. This is the ideal case, but practically it is not looking like this, that it will showing some curve here, and it will showing the different region. In different region it will provide it like this. Okay, so this is the transition of that, and you can focus it. Okay, the output till this it is high, and after this it is low. In between this voltage, that before that this is, let this is VTH, and let this is VDD minus VTH. Okay, so if the input is less than VTH, what is happening? If the input is less than VTH, you are providing the input is less than VTH, this NMOS is off. And if this NMOS is off, what is happening, that the only PMOS is active and NMOS is off. And that PMOS can be linear, can be saturation, we will discuss later. But there's in this point that whenever the input voltage is less than VTH, because the input is same for both there. This is VSG, that is VDD minus V input is greater than equal to VDD minus Vin is greater to mod VTS. That is the condition for PMOS. If you are looking for NMOS, this is Vin minus 0 greater than equal to VTS. That is the condition for NMOS. If Vin is not greater than equal to VTS, then the pull down network is off. That NMOS is off. If NMOS is off, that means this is open circuit, that the current through the NMOS is 0. The current through the NMOS is 0. If the Vin is less than VTS, the NMOS is off, that PMOS will provide that higher voltage. Why? Because the only PMOS is on. And if you have a basic condition, that is VDD minus Vin is greater than equal to mod VTH, that means VDD minus mod VTH is greater than equal to mod VTH, then VDD is always greater than that. That means PMOS is on. And you will check it in which region it is on. It may be linear, it may be saturation, it may be cutoff. Which region you will prefer? So I am just assuming that let this V input is this point and this point and this point and this point and this point. Let's check it with a different region. When V input is 0, so VDD minus 0 is greater than equal to mod VTS. That means PMOS is on. 0 minus 0 greater than equal to VTS, that NMOS is off. And at this point, what is the region of the PMOS? If PMOS is on, just put it VSD, not it VDS. Put it VSD is greater than equal to VSG minus VTH for saturation region. If this condition is true, so PMOS in saturation. If this condition is not true, so the PMOS in linear region. Just check it there. So that source voltage is VDD, the drain voltage is Vout is greater than equal to the source voltage is VDD, the gate voltage is nearly 0 minus mod VTH. Okay. Vout is nearly about VDD, so VDD minus VDD is 0 greater than equal to VDD minus mod VTH. It never be happen, so VDD minus VTH is less than 0. It never be happen. So that means the saturation condition is fail. Means the condition is what? VDD minus mod VTH is greater than equal to 0. So this condition for linear. So I can say that this region is called PMOS in linear and NMOS in cutoff. Okay. And you can look at here that NMOS is off, then only that PMOS is providing that, and you have a higher voltage. PMOS is good for charging, so it will be that VDD. PMOS is on and output is reaches to VDD, and in this region that NMOS is off and PMOS is in linear region. Let's talk about at the point of VTH. If you are looking at this region, that the NMOS is nearly to VTH, the input voltage is near to VTH. What is happening? If the input voltage is near to VTH or greater than that, a small value of that, what is happening through a NMOS? V in minus 0 greater than equal to VTH. For NMOS on, V in minus 0, that VGS is greater than equal to 0, just like I am using a past transistor concept, V in minus 0 greater than equal to VTH, and if V in is VTH, so this condition is true, that means NMOS is on. At this point, the NMOS is on. That's why the graph is going towards down, because capacitor is discharging, Vout is discharging, because Vout have a capacitor is discharging. The NMOS is active when the input is greater than VTH. When the input voltage is greater than VTH, the output, the capacitor voltage Vout, that is VDD, is trying to discharge. And firstly check it, if it is on, so what will be the current? So current is what? That is VDS is greater than equal to VGS minus VTH, or you are saying that VD greater than equal to VG minus VTH. The drain voltage is your VDD. It is nearly about the drain voltage. This is drain of the NMOS. This is the source of the NMOS. This is source of the PMOS. This is the drain of the NMOS. So if you are looking that terminal VTH and VTH, it is greater than equal to 0. That means the condition is true, that VDS is greater than equal to VGS minus VTH. I can say that this is the point where that NMOS in saturation. And let's talk about PMOS. Let's talk about what is happening through a PMOS. Okay. So in the same condition, VDD minus V in is VTH, VDD minus VTH is greater than equal to VTH, that means PMOS is on. VDD minus VTH is greater than equal to mod VTH, that means that PMOS is on. If PMOS is on, check it MOSFET in saturation or linear, just put it VDD minus Vout is greater than VDD. Here the gate voltage is not 0, it is VTH. So VDD minus VTH minus of mod VTH, that means VDD minus Vout, VDD minus VDD minus VDD is greater than equal to VDD. It is not true. That means this condition is linear. So PMOS is here in linear there. Okay. So as per that, you are going in such a way that PMOS in linear, NMOS in cutoff, in till this region that PMOS in linear, NMOS in cutoff, in this region till this region that PMOS in linear, NMOS in saturation. If you are looking this point, you will find it that NMOS and PMOS both are in saturation. PMOS and NMOS both are in saturation. You can check it. And after that you will find that PMOS in saturation and NMOS in linear. At this point you will find it okay that PMOS in linear and PMOS in saturation, NMOS in linear, and lastly you will find it PMOS in cutoff and NMOS in linear. Just check it. Okay. So this is the way that the different region you have, and by the basic equation you can determine it. And if both region in saturation, if both region that at the point of VDD by 2, when both region are in saturation, the PMOS and NMOS both are in saturation, that is the point where that you will find that maximum current. The point at which both MOSFET in saturation region, or you can say that the maximum power dissipation by the CMOS circuit is happening at when both MOSFET in saturation region. If PMOS and NMOS in saturation region, you will find the maximum power dissipation is happening through the circuit. Okay, why? Because both in saturation, both have a maximum current, and both have a maximum current, that is VDD into that current will be your power dissipation. If you talk about one is linear, one is cutoff, one is cutoff, one is linear, both in linear, one is saturation. If you are looking this, so one of that provides the higher current, one of that provides the low current. If it is this is linear, this is cutoff, the total current is 0. So VDD to ground, the current is 0. The power dissipation is 0. So when that NMOS is on and PMOS is off, if you talk about 0 or VDD, so PMOS is off, NMOS is on, that the current through the PMOS is 0, the NMOS have a current, so that current, that power dissipation is 0. But if both have a current is maximum, that is both have a saturation current, let this is saturation current and this is that both MOSFET is behave like a current source and you have a VDD. So you can determine it, that is VDD into ID side and ID side. So VDD into ID side will be your power dissipation. So the power dissipation is happening, the dynamic power dissipation, because here that input is changing. The input is changing at this point and the output is changing from VDD to 0, and this is called the threshold voltage of the CMOS inverter. And at this point you will find ideally that Vout is VDD by 2. The input at VDD by 2, the output is also VDD by 2. That is called the threshold voltage of the CMOS inverter. Or you are saying that the state is changing from higher to low. That is called the threshold voltage of the CMOS inverter. You can shift your threshold voltage left to right by the help of W by L parameter changes. But here it is what is happening. I am just saying that ideal case that VDD by 2 pe VDD by 2 is occurring, that is called the threshold voltage of the CMOS inverter, and the region is defining the current. That if you have this region, that PMOS in linear, NMOS in cutoff, that you will find that zero current, nearly zero current, that is nanoampere current. If one is linear and one is saturation, it will not provide that high current. If both are in saturation, you will find the maximum peak current, that is called the trip point. The point at which you find the maximum current, that is called trip point. Trip point, at the point at which you will find the maximum current, that shoot is happening, the current will shoot to that voltage, that is called trip point. And as per that going on, that VDD by 2, VDD minus VTS to VDD, that current will decrease as per that NMOS is on and PMOS is going towards off. So that's why this is happening here. And We will discuss what will happen when I am using this resistor, what is happening through a resistor here. If I am using a resistor, what will happen when I am changing the W by L of this? How can we set that the threshold voltage of the CMOS inverter? We will discuss and we will simulate it also. Okay, so for now, thank you so much everyone. Please work on it because the CMOS inverter is very important topic. They can ask in a such a way, what is the region here, what will be the region here, what will be the region here, or I can replace the PMOS in place of NMOS, and NMOS is replaced with PMOS. What will happen if you have a NMOS in upper side pull up network and PMOS in lower side? That output is not reaches to VDD, it will be VDD minus VTH. That output is never be zero, it will be maximum to VTH. So that transition is happening, that input is lying this, the output till VTH it will maintain, and after VTH it will be retest to VDD minus VTH. So it is looking like a buffer, but it is not a good buffer. It will be a weak buffer when you are replacing that PMOS with the NMOS. So the weak buffer means it will not provide the maximum voltage to VDD, it will not provide to zero, it will be in between VDD minus VTH to mod VTH. Okay, so if you are replacing the PMOS and NMOS, it become a weak buffer. Okay, so I hope you can understand this part. Please focus on that and please focus on the past transistor based question because they are directly related with your interview, and we will discuss later as per parameter variation, as per what will be happen if you are using resistor and capacitor here. Okay, so thank you so much everyone. Bye bye, take care.